Today I start now sets. With previous class we discussed about subset, definition of subset, superset, and union of set, intersection of set. Now we start disjoint set. Which one is called disjoint set? Consider two sets A and B, two set. If A intersection B equal to phi, then A and B are disjoint set. Where phi is the empty set. Phi means contains no element. A for A or A equal to 0, that means 0 belongs to this set, one point set or one element set. But phi is no element, contains no element. If then this one is empty set. If A intersection B equal to empty set, then this A and B are called disjoint set. Then here A we construct some set which contains some lines, and B some set contains some colorful dots. Then these two sets are disjoint. And here also A equal to 1 2 and B equal to 3 4, then these two sets also disjoint. And any set with properties of some set containing phi, for any set A union phi equal to phi, A union phi equal to A, and A intersection phi equal to phi, and phi subset of A. That means X belongs to phi implies that X belongs to A. This implies phi subset of A. Okay. Now we simply set next we simply set contrapositive and converse, that use in mathematics and also use in some proof, some lemmas, and also some statement. We draw some statement and we find some contrapositive and converse also. Now we start contrapositive. Okay, contrapositive, how we define it? We define it if P hold, then Q hold. And contrapositive, some statement is this, some statement, then contrapositive of this statement. If Q does not hold, then P does not hold. That means P implies Q. Contrapositive of this equal to not P, not Q implies not. We construct some basic examples. Which examples? Simple, we draw if x greater than 0, then minus x less than 0. Contrapositive, this one is statement, then contrapositive is if minus x less than 0 does not hold, then x greater than 0 does not hold. And create another example. So simple example, if x greater than 1, then x plus 2 greater than 3. Contrapositive of this is so simple, if x plus 2 greater than 3 does not hold, then x greater than 1 does not hold. Okay, so we construct and we use contrapositive in further. So we know this contrapositive. Now next we know converse. Converse of some statement, and this converse use we in any theorem conversely we prove it. Okay, so we know now converse. Converse means if P hold, then Q hold. This one is some statement. Then converse of this statement. Converse of this statement be if Q hold, then P hold. Okay, that means in short way P implies Q, converse is Q implies. Next we see some examples. If x greater than 0, then minus x less than 0. Converse is if minus x less than 0, then x greater than 0. Create another example in simple way. If x greater than equal to 2, then x plus 1 greater than 3. Converse is so simple. If x plus 1 greater than 3, then x greater than 2. Okay, in this way we know converse and use it further in mathematical statement or prove some theorem lemma in use in many ways. So we now know converse. Also we know some statement P implies Q and converse is Q implies P. If both hold, then we know P implies and implies by Q. This implies P if and only if Q. That means P hold if and only if Q hold. Okay. We see it in example also. We construct some example also. How? If x greater than 0, then minus x less than 0. Converse is if minus x less than 0, then x greater than 0. We write it in this way: x greater than 0 if and only if minus x less than 0. Okay, that means if in this way x greater than 0, if and only if minus x less than 0. So we write this one also. Next we further proceed negation of some statement. Negation if that means P hold, then negation is not P hold. Okay, so simple way we write it. How? We see example. For every x belongs to A, statement P hold. Then negation is So simple. For at least one x belongs to A, statement P does not hold. Okay, and same way we draw negation for at least one x belongs to A, statement Q hold. Then negation is so simple. Negation is for every x belongs to A, statement Q does not hold. Does not hold. Okay, now we write some collection of set, and this one is the sets contain some sets. That means power set of A, which contains all subsets of A. Okay, we construct A equal to 1 2, then power set of A equal to 5 singleton 1 singleton 2 and 1. That means a set which contains some sets as elements of set, then this one is the collection of sets. Okay, so we draw and we known collection of sets, and example is power set of A. Now we start difference of two set. Okay, difference of two set. Difference of two set. We know need A and B be two set. A difference B equal to those x such that x belongs to B and x does not belongs to x belongs to A, x does not belongs to B. That means complement of B related to A or in A, or complement of B in A, or with respect to A. Okay, how we see in example? Now we draw some figure A, some B. A is here, B is here, then this one is A intersection B, and so which one is A? No, this one is A difference B. So okay, this one is A difference B, and obviously this one is B difference A, this one is B difference A. Okay, so we see some example. A is 1 2 3 and B is 2 3 4, then A difference B equal to singleton 1. Okay, so we know the difference of two sets. Today we stop here.